Today we are going to go through your geometric solid study guide. So the first part says to match the geometric solid to its description. So we have cylinder, cone, pyramid, rectangular, prism, and sphere. So let's see if we can match these up. So the first one, a solid object with identical circular bases and a curved side. Well, our only solid here that we had two identical circular bases was a cylinder. So that is A. Next one, a solid figure where the base is a polygon and the sides are triangular faces that meet at the apex. Well, our only apexes were pyramids or cones, but notice how this one says triangular faces. So a cone did not have triangular faces, but pyramids did. So this one is B for pyramid. Next one, a solid figure where all sides are rectangles and all sides meet perpendicular. That is our rectangular prism. A solid with a circular base and a curved side that tapers to a point. So this is our cone. And then last one, a round solid figure where every point is equidistant from the center. So that is definitely our sphere. All right, next we're talking about slicing figures. So the main thing to remember is whenever you are slicing horizontally, the shape is going to match whatever your base is. And then when you're slicing vertically, your shape will match whatever your sides are. Okay, so if we were to cut a sphere vertically, okay, so when we're cutting a sphere vertically, it's going to match whatever our sides are. So a sphere doesn't really have sides because it's curved. However, if you slice a sphere vertically or horizontally, you are going to get circles. So this will be a circle. Vertical cut of a square pyramid. So again, vertical, you need to think of whatever the sides are. So as we know on pyramids, our sides have triangular faces. So if you were to cut a square pyramid vertically, you will get a triangle. Vertical cut of a cylinder. So again, thinking about our sides, our cylinder does not have faces as sides because it is curved. However, when you do cut it vertically, it will give you a rectangle. Horizontal cut of a square pyramid. So now we're thinking of the base. So our base is a square, so that means when we cut it horizontally, it will also be a square. And then horizontal cut of a cylinder, our bases are circles, so that means when we cut it horizontally, it will be a circle. All right, next part is talking about faces. So remember, faces are all of the flat pieces on our solids here. So we are just going to put a check in the appropriate box for each figure if it has that face. So when we have a rectangular pyramid, your base is a rectangle and that is a face, and then your sides are also triangles and those are faces as well. So a rectangular pyramid has the rectangular face at the bottom and then triangular faces on the sides. A triangular pyramid, you have a triangle on the bottom as your face, as your base, and then triangular sides for your faces. So all that you have for your faces are triangles. A sphere has no faces because, as we know, a sphere is like a ball, and we cannot lay a ball flat on any of its sides because it's all curved. So we're going to leave this one blank because it has no faces. The cone, we do have a circular face for the bottom of it, and then the rest of it is curved, so it only has a circular face. Right rectangular prism, we have rectangles on all the sides, so they only have rectangular faces. And then square pyramid is very similar to a rectangular pyramid where you have a square as the base. So a square can be classified as a rectangle, so we are going to put a check mark there. And then your triangular faces are your sides. All right, and now talking about number of edges and vertices. So remember, edges are all of like the sharp sides that form your faces together, and then vertices are all of like your corners or the points on your figure. So rectangular pyramid here, I have a square pyramid, but they're very similar to rectangular pyramids. Number of edges, so we have the 4 on top that create our triangular faces, and then we have the 4 on bottom that create our rectangle. So in this case, we have 8 edges. And then vertices, you have the apex at the top, and then you have the 4 on the sides that create your square. So you have 5 vertices total. All right, moving on to triangular pyramid. So your edges, you have 3 on top that form the 3 faces together, and then the 3 on bottom. And then the 3 on bottom that form the triangle. So 3 plus 3 would be 6 edges. Number of vertices, you have the apex at the top, and then the 3 that make up the triangle down here at the bottom. So you have 4 vertices. For a sphere, notice how we have no sharp edges that form faces together. So there's 0 edges as well as 0 vertices because there's no points. So 0, 0. For a cone, once again, we have no edges because we have no sharp edges that form our faces with anything. So 0 edges. And then your vertices, we do count the top here as a vertice. So you do have 1. Right rectangular prism, so we do have a lot of edges on this one. So I always start with the front here. So we have 1, 2, 3, 4, 5, 6, 7, 8. And then you can't count the ones that you already counted when you counted the front and the back. So I have 8, 9, 10, 11, and 12. So I have 12 edges total. Vertices, again, are all your corners or the points. So I have 1, 2, 3, 4, 5, 6, 7, 8. All right, and then again, square pyramid is very similar to a rectangular pyramid. So you have your 4 edges on top and the 4 on bottom. So you would still have 8 edges. And then vertices, again, you have your apex and then 4 on bottom. So you have 5 total. All right, number 13, so the unit of measure for surface area is always measured in, so whenever we're talking about area, it's always squared units. And then the unit of measure for volume is always measured in cubic units. Okay, so area is always squared, so it'll be like inches squared. Volume is always cubed, so it'd be like inches cubed. All right, so we have your formulas at the top here, and then you just have to pick the formula that goes with the object here. So here I have a rectangular prism. As I know, to find volume of a rectangular prism, you're using your length times width times height formula. So volume equals length times width times height. My length is 17, my width is 11, and my height is 12. So all I need to do is just multiply all those numbers together. So 17 times 11 times 12 is going to give me a total volume of 2,244 cubic centimeters. All right, next one, number 16. Looking at my base, I have a square because my side lengths are 18 and 18, so they are the same, so it's a square. And then my sides come to a apex at the top, so this is a square pyramid. So a square pyramid has the volume formula of 1/3 s squared h. All right, so I'm going to keep my 1/3. S means side of your base, so that is 18, and we're going to square it. And then the height of the pyramid here is 16. All right, so then again, you're just multiplying. So 1/3 times 18 squared times 16 is going to give us a total volume of 1,728 cubic feet. All right, moving down here. So here I have a cone. Cone had a very similar volume formula to a cylinder. However, because of how my top here comes to like an apex, it's very similar to a pyramid formula as well, which is that 1/3 in front of it. So the volume formula of a cone is 1/3 pi r squared h. In the directions up here, it did tell us to use 3.14 for pi. So we're going to substitute in 3.14 for pi. Our radius, remember radius is the line that goes halfway through the center of the circle. So they gave us the line that goes all the way through the center of the circle. So to get the radius from the diameter, you just take this 16 and cut it in half. So in other words, 16 divided by 2 is going to give me a radius of 8. And we're going to square that. And all right, and then again, you're just multiplying. So 1/3 times 3.14 times 8 squared times 17 is going to give you a total volume of 1,138 point, and we're rounding to the nearest hundredths here, 77 cubic centimeters. All right, and then for a sphere, we need to find the surface area and the volume. So our surface area formula for a sphere is that 4 pi r squared, and then the volume formula is that 4/3 pi r cubed. Okay. All right, so again, we are going to plug in 3.14 in for pi. And then they do give us the radius here, so our radius is 10, and we're going to square that. So if you multiply here 4 times 3.14 times 10 squared, that is going to give us a surface area of 1,256. And we are talking about centimeters. And since we are doing surface area, remember surface area is centimeters squared. All right, and then volume. So keep your 4/3. Again, plug in 3.14 for pi. Our radius is 10, and this time we are cubing it. All right, so again, just multiply. So take 4/3 times 3.14 times 10 cubed, and that is going to give you a total volume of 4,186.67 cubic centimeters. Because again, we're rounding to the nearest hundredths. All right, last page, just a couple of word problems here. All right, so Amanda builds a sandcastle using 2 plastic molds. One of the molds is the shape of a cone with a height of 5 inches and a diameter of 6. The other mold is the shape of a square pyramid with a height of 6 and a side measurement for the base of 3.2. What's the difference of the volumes of the 2 molds? All right, so we need to find the volume of the cone as well as the volume of the pyramid. So volume formula of a cone is that 1/3 pi r squared h. They do want us to use 3.14, so this would be 1/3 times 3.14 times a radius. Again, they gave us diameter, so we need to divide this 6 by 2 to cut it in half to get the radius, which would be 3. And we're going to square that, and then times the height of it, which is 5. All right, so when we multiply all those numbers, so 1/3 times 3.14 times 3 squared times 5, you get a volume of 47.1. All right, now we need to find the volume of our squared pyramid. So square pyramid has a volume formula of 1/3 s squared h. They tell us that the height of the square pyramid is 6 and the side measurement for the base is 3.2. So this would be 1/3 times 3.2 squared times 6. And again, when you multiply all those numbers, you will get a volume of 20.48. All right, so the last thing we need to do is they want to know what is the difference of the volumes of the two molds. So difference means subtraction. So we are going to take the cone's volume, since it had the highest volume, minus the pyramid's volume, and just plug that in your calculator and you will get 26.62 cubic inches as the difference. All right, number 20, Peter is creating a scale model of the Earth for science class. How much paper will he need to cover a ball that has a diameter of 24 centimeters? So we're trying to cover a ball here, so that is a sphere, and we just need to know if we're finding surface area or if we're finding volume. So remember, if we're talking about the outside of the figure, that's surface area. If we're talking about the inside, that's volume. So if we're trying to figure out how much paper can we use to cover the ball, that is surface area. So our surface area formula for a sphere is 4 pi r squared. They do want us to use 3.14 for pi. And our radius, again, they gave us diameter, so we need to cut that in half to get the radius. So half of 24 is 12. And then again, we are just multiplying. So 4 times 3.14 times 12 squared is going to give us a total volume of 1,808.64 squared centimeters. Again, it's squared because it's surface area. All right, next one. Miguel is filling his spherical shaped fishbowl with water. The fishbowl has a radius of 10 inches. If he is only supposed to fill the fishbowl 2/3 of the way to the top, how much water will Miguel need to use? So this time we are talking about a sphere again, but we are filling it up with water, so that's talking about volume. So our volume formula of a sphere is 4/3 pi r cubed. And again, they do want us to use 3.14 for pi. And this time they do tell us that our radius is 10, so we're going to take 10 cubed. So when we find the volume of the entire fishbowl, it has a volume of 4,186.67, because again, we're rounding to the nearest hundredths. But that is not our final answer, because they are wanting to know if we were to only fill it up with water 2/3 of the way full, then how much water will he need to use? So our last step is to take our volume, so this 4,186.67, and we need to multiply it times this 2/3, because we're only going to fill it up 2/3 of the way full. All right, so when we take 4,186.67 times our 2/3, we are only going to fill it up with water for 2,791.11 cubic inches. All right, and then last one here, a swimming pool is shaped like a rectangular prism. The pool is 12 feet long, 7 feet wide, and 6 feet deep. Chlorinated water must be used in the pool. A pool company charges $30 for every 21 cubic feet of chlorinated water. How much will it cost to fill the pool with chlorinated water? All right, so first step here is to find the volume of the entire pool. So if it's a rectangular prism, our formula is length times width times height. They tell us that our length is 12, our width is 7, and our height is 6. So if you multiply all those numbers, our pool has a total volume of 504 cubic feet. Okay. So a pool company charges $30 for every 21 cubic feet of chlorinated water. So we need to know how many 21 cubic feet is within 504. So to figure that out, you just need to take your 504 and divide it by 21 to figure out how many 21s are within this 504. So 504 divided by 21 will give you 24. So that means we have 24 of the 21 cubic feet of chlorinated water within our volume of 504. So last step is to take, if they're going to charge $30 for every 21 cubic feet and there's 24 of them, your last step is to take that 24 times how much it's going to cost, and that's going to give us a total value of $720. Alright, so that is your guys' study guide. If you have any questions, please let your teacher know.